ahead.
Okay, so my function name was synthetic data. And then, so for the department list, that's the 5 departments, and then the gender was either a male or a female. So so I use the round in to generate the student ID, and then I set the limit to be 109000 and then 2000. And then for the age, I also use the round int because I wanted it to be an integer between from 19 to 27. And then the exam score too, I used uniform because I wanted a floating point. And then for the gender, I used choice to get either a male or female from the gender list from above. And then department too, I used the choice method to get a random department from the department list from above. And then the CGPA, I used uniform because I wanted a floating point. And then, so for the CGPA, I wanted the decimal points to be 1. So I rounded it to 1 decimal place. So from here, then I had an empty list. So after each iteration, it gets appended into the data from above. And then I change everything to an array so that I can work with it. So when I set the size to 200, I got the array. And so I checked the type and it was an array. So from there, I changed it to a data frame. And then I set the columns as they were given. And then I checked the info. And everything was an object. But then we were asked to change the gender and then the department too. We were supposed to encode them. So this is what I used. So before I started everything, I imported NumPy, Pandas, Random, and then the sklearn. So at this point, from sklearn, I imported pre-processing, and then I set a variable as encoded object, and then I got label encoder from the pre-processing, and then I set another variable x. So I use fit, and then the gender. So I wanted to encode the gender. So I did that, and then I got this. So I did the same for the department, and then I also got this. Yes, so please, that's what I did.
Thank you very much. Thank
Yes,
you very, very
but
much.
please, I have a question.
1 minute. So, exactly.
Okay.
So, what you have done is what we were expecting the class to do. Well, these are random information. So, at least you cannot have 2 segments because if you are doing classification by gender, then when you, I understand what you have done because we wanted it to do it this way so that we can see. So in the future, if we are to do classification by department, we know what to do. Then classification by gender too, we also know what to do. So please, if you want to ask a question, go ahead with your question.
Okay, so please, from when I checked the info of the data that I generated, I realized that the data type of all of them, the student ID to the CGP, everything was object. So I'm asking why, even from here, even though I set the student ID to be an integer, why is it that over here is appearing as an object and not integer? And then same for the CGPA and then the age and exam score.
Okay. So who would like to answer her? Anybody who would like to make somebody's raise their hand? Who is that? Please, would you want to talk? Yes, anybody who would like to contribute to the discussion? Okay, Ken, please go ahead.
Hello, please, can you hear me? Hello. Hello.
Yes, please go
Yeah,
ahead.
we can hear.
So, yes, that's a very good observation. That's the actual attack. But then the point is the objects fully specific. They are we have the data frame says that's what I would say that like with the object and in data type, the object. And then based on what you have spoken in relation to the fact that you have originally started with currently assistant.
Ken, it appears your voice is very, very low.
Please, is it better now?
Yes, it's better. Can you start all over because it was very, very low, so they were not hearing.
Okay. So the point I was making earlier is up until now, okay, we realized that the primitive, yes, that's how we call it, the primitive data types we have been working with. The original ones were the int, the floats, the string, and all those things, okay? It is only when we started using the pandas data frames that we see some as objects. So you recall that the earlier data that we were, for instance, the iris data sets, we saw that when we did whatever.info, we saw the data type as, let's say, floats 64 and 32. And I was trying to explain to you that, well, with the pandas data set, it is very specific on even the bit size of the data that we have. And in the last one, if you recall, that was the species, that particular column where we had the iris setosa, iris versicolor, and all those things. That was where we were seeing objects. Now, this object data type, which is only specific to pandas data frames, is more or less the default data type that can accommodate any other data type from the primitive versions. So when you typically see objects like this, without even going through the specifics of that data type, we can assume, okay, this object can be either an int, a string, or anything. It can even be a list that is embedded in there. So that's a clear distinction. But then this is only specific to how do you call it, data frames. So you cannot say Python has a primitive data type called object. No, it doesn't work that way. It is only specific to data frame. And when it is an object, it can be any of the other data types that we spoke about earlier.
Okay, thank you.
You're welcome.
So please, I'm done.
Okay. Does anybody else want to contribute? Yes, Philemon, please. Or Philemon, you can share.
Okay, so I generated the data using Excel. Gave the student's name, age, exam score, gender, departments, and the CGPA. Then I then
You saw
imported
that
it.
they are missing values in there? Did you
Yes,
do
I
that?
intentionally
Okay.
added missing values into the
Oh,
data
very
set
good. Okay, very
to
good.
clean it. So I imported the pandas library, numpys library. I imported this warnings library because for some reason I was getting some warning error, some warnings for some of the things I was doing. So I wanted to ignore those warnings. So I read the spreadsheet into this data variable and looked at it. And I also added duplicates to it. So I could also clear the duplicates as part of the cleaning. So from describing the data frame, I could see that the count was 206 for the ID, but the maximum ID in the set was 200, meaning there were some extras inside the data set. So I dropped the duplicates, and then after I dropped duplicates and then previewing the data set, I can see that the duplicated thread that was here is gone, and even the ID, the row number has also changed from 1234 to 124 because there was a duplicate as row number 3. And then doing that now, I can see the count of the ID is 200, which is matching the max count of the IDs in the database. But then again, the age, exam score, and the CGPA are not matching the number of IDs inside the database because there are some null values inside. And I can see that by doing the info, that there are only 195 non-null values inside the age, exam score, and the CGPA. Meaning for this one, there are 5 values out, there are 6 values out, and there are also 5 values out of it. So, so I calculated the mean age by rounding it to rounding it without any decimal places for the data age mean. And then the CGPA, I also did the same thing. But for the CGPA, I didn't round it up since it is a floating point value. The exam score, I also found the mean of the exam score. And I just printed them out to look at it. So then I filled the null values, the age with the mean age, the CGPA with the mean CGPA, and the exam score with the mean exam score. And I placed it back into the data sets using this line. And now looking back at the info, it now shows everything has been filled fully. No more null values are inside the database. I imported the label encoder from sklearn to convert the gender, the gender column into a form that is readable by the system, and then the department is a form that is readable by the system. I couldn't convert the name because the names are random. So I converted the gender and the departments into a form that is readable. So the male was 1 and female was 0. And for the department, CPEN was 2, MPEN was 4, FPEN was 3, BMEN was 1, and AREN was 0. I just did the correlation. That's all from what I did.
Thank you very much. So you also went through another approach. You use Excel to do the data generation, and then you imported it in the Python, and then you started using that. And then you also introduced some missing values and things, and the outliers. Did a cleaning. So that is also quite good. At least we have now come to see that at least some of you are following what we are doing, and given the opportunity, you're able to do great things with the knowledge that you have acquired. So Ken, do we move from here now?
Yes, but then let me also add something to my brother Philemon. Please share your screen back. I want to show something. Okay, just here. So this is just for you to understand some few things. Now, when you are doing the label encoding, it is definitely no. Where we are, just scroll down. Yes. When you are doing the label encoding, what usually happens behind the scenes? Okay, so it is going to change all, let's say, instances of a particular kind, okay, and I'm choosing my words very carefully, all instances of a particular kind, and we assign a categorical value to it. So let's say 1 for all semen, 2 for all, whatever, 3 for all, whatever. But then what actually happens behind the scene is it actually looks at it in alphabetical order. So over here, you see that Rn had 0. Remember, Python start counting from 0, and it is 0 because based on the alphabetical order, A starts first. Then it came to Bmen, which is right after A. So we had 1 over here. Then it went to Cpen, which is also right after B, before M10 was the last one. In the case of males and females too, we realize that when we are reciting ABC, we get to F before M. So any other one that you may do. So on Tuesday, remember we did Ghana, Nigeria, and Togo. And I believe Ghana was 0 because when we are doing those recite, I mean, ABC, Ghana comes before N and then before T. So that's how we got about those particular ones. So that's just a brief one. I think, Dr. Mills, now I can start with my presentation. I have some few things to.
Yeah, so at least, you see that, at least we have seen that some of them are following what we are. That's the most important point for me.
Yeah, sure.
So.
Okay, so I'm briefly going to share my screen and we are going to make progress. Today I have a lot to cover and I hope you have the time to actually go through everything. Okay, so all right, so once again, guided by our outline, we are going to complete the very things we have over here. Now, today I'm going to briefly touch on data visualization. And like I always say, we are just scratching the surface as and when some new concepts become necessary, learn them as we go. So today we are going to see how we can visualize data. And this data visualization process gives us some leverage, okay? Gives us the opportunity to even see if, for instance, there are some, let's say, outliers in our data sets. So it is not mutually exclusive from me trying to process our data or trying to see if there's some class imbalance and stuff like that. So we are going to see some various tricks that we can follow. So what I'm going to do is I'm going to open up my Jupyter Notebook environment. So I'll quickly do that. And I'll create a new workbook. Create a new workbook and let me rename this quickly. So I'll call this data. Okay. So like we've always seen throughout the process, there's a lot of libraries that Python has. Okay, Python has a lot of libraries. And for which reason, depending on whatever thing we may want to do, there's some kind of a library that we use. So if we want to deal with some numerical data in the form of matrices, arrays, then we follow NumPy. If we want to import data, do some data cleaning, then we follow on Pandas. So if we want to do visualization of data, there are basically 2 popular libraries we deal with. And those libraries are Matplotlib. Okay, so Matplot library kind of, and then the other one is it has an interesting name called Seaborn. So we are going to use Matplotlib and Seaborn to do a visualization. Now it turns out that there are 2 different libraries altogether, but then it's almost as if they kind of do the same thing. Okay, so for instance, if you want a distribution plot, okay, or like a histogram. You can use Seaborn to draw the same thing. You can equally use Matplotlib to draw the same thing. If you want a pie chart, you can use Matplotlib and also Seaborn. Okay, so I'm going to show you instances where we use exclusively Matplotlib and instances where we use Seaborn and instances where, for instance, you can even combine them. Okay, use this one for this and use another one for another thing, and it all works. So in order to get this, once again, you need to have it installed on your system. So like you always do, you just come into your command prompt and you type pip install and matplotlib this way. So you can do pip install matplotlib, press enter, or you can install both. Okay, so when I do pip install matplotlib, then I leave a space, Seaborn, if I leave a space and NumPy. What it means is, okay, I want my system to install Matplotlib Seaborn and NumPy. Okay. I can equally add, let's say, that's over here, and everything will be installed. But then I believe we all have the NumPy and the Pandas, so we just need Seaborn and Matplotlib. So press enter and the installation proceed from there. I already have it installed, so I don't need to think about this again. But then what I can do in order to show you is to do a pip list. And this is basically going to list all the libraries I have installed on my system. So clearly, yeah, quite a number. So I'm looking for Seaborn, and I believe this is Seaborn. So see that I have Seaborn, and this is a version I have. I believe if you are to install yours now, probably you are going to get a newer version than I have. And then the Matplotlib will be up here. Yeah. So this Matplotlib, and this is a version of Matplotlib I have for my system. Okay. So now that I have those two libraries, I can import them. So I'm going to say import Matplotlib. But then doing it this way is not going to work. Once again, Matplotlib is a very big library, so it has a lot of packages in there. So I can say import matplotlib.pyplot. It is this pyplot that we are going to use. And normally what you see people do is they'll give it an alias as plt. So I can say import matplotlib.pyplot as plt. So that means if I go into Matplotlib, I want to go into pyplot, and now I'm doing the import of pyplot as plt. Alternatively, I can say from matplotlib import pyplot as plt. So this and this, they are literally the same thing, okay? But normally I prefer to have it this way because this more or less like everything makes sense. From matplotlib import pyplot as plt. It's kind of very cool. It's almost like this is how I see it. It's almost like somebody writes I am, let's say I'm fine. Okay, and somebody writing English, same English, and somebody say I'm fine. If you are learning English for the first time and you start seeing some of these things, you get okay. This is very simple for you to understand. So this is how I look at it. So we can just stick to one, and I'll stick to what I like. So this one, from matplotlib, import pyplot as plt. And then I'm going to also say import Seaborn, which is the other library, as SNS. This is what you see a lot of people do. Now, as to whichever names you choose or whichever aliases you choose over here, that one depends on you. So I'll do a shift enter to run this. And remember, these libraries are only helping us, for instance, do the plotting. So if we have our data set in an Excel sheet, that means we need to import it first before we do the visualization. So in that sense, we'll probably fall on, let's say NumPy and Pandas and those things. So I'll say import NumPy as NP and also import Pandas as PD. Then based on what we know, that even in scikit-learn, we can have some data set in there. So let's also import that and see what can we do. So I'm going to say from sklearn import data sets. So now everything looks good for me. And now let me run this. So let's start off with the very basics, okay? And there are lots of plotting that we are going to do. But like I said, we cannot cover everything. So we are going to cover the very important ones. And as and when it becomes necessary, we just introduce something. And the plotting is almost like any other thing that we do. Okay? So back in the days, we had graphs, we were plotting. So normally you have your x-axis, your y-axis. The same concepts apply over here. If it is a pie chart that you want, you shouldn't be thinking about x-axis and y-axis. All that you need to be worried about is the data. For instance, the angle, okay, in terms of how do you think about that? Is it a sector or whatever? Okay, that's sec. Those are the things you should be worried about. If it is, for instance, a histogram, yes, you should be worried about your x and y, and then also the width of each bar. Okay, I mean the bar plots and all those things. All right. So we are going to start off with the basics. So let's say we have some data, okay, which is x, and this x is going to be an NumPy array. So we are just generating some data. So I'm going to say 1, 4, 7. Okay, so somebody is saying my microphone isn't very clear. It's the same with everyone, or it is okay?
It's a bit better, but formally it wasn't very clear enough.
Okay, sorry. All right, so this is the data that we have with x, and let's say this is the data we are also going to have with y. So I'm going to say np.array, and also y is going to be, let's say 10, 5, and then 9. So this is just some random data I'm putting up. So I run this, and then we have this saved inside of our memory. Now I want to do, let's say, some plotting. So the first one we are going to do is just to have some line plots, okay? So I just want to have an instance where I can plot these values on a line. So now I'm going to fall on PLT, which is the matplotlib or the pyplot inside of matplotlib. So I can say PLT dot plot. So now when I do PLT dot plot, I need to pass in the data. So the data I want to plot is this. Now when I do this and run this, I have this line showing up over here on this plot. Now this looks a little bit interesting, but then let's look out for the key things. So we're just plotting x. This one is just x. So it is just looking at x. Now it looks at the first value. The first value over here is 1. So it plots 1 over here. It looks like at the second value it is 4. 4 is somewhere here. We are not seeing it, but later on we are going to see how we can do some dots in there and stuff like that. And then the other value is 7, and that's what you see over here. Now you see that y-axis is actually the values of the data that we have over here, and our x value is just some random spacing it has given us. Okay. So this one looks good, and by default the color is blue. We can change the color to any other color that we want, and we can modify a lot of things over here. So this is just one way of doing it. Now let's look at another way. I can do plt.scatter. So this is going to be a scatter plot, and the scatter plot will just basically put the dots in there for us. Now when I do x, once again something interesting happens. I get a problem, because this time around with the scatter plot, I need to have a y component, because it needs to point things in the x and y direction. So of course I have some y values over here. So let's say I have for my y. So I run this and I have a scatter plot. So now the first plot is, okay, I need to put a point or a scatter where the x is 1 and the y is 10. So over here, look at this, the x is 1 and the y is 10. So I put a dot over here. Okay, that looks good. The second one is when our x is 4 and our y is 5. So x4, y5. This is x4, and then y5 is showing up. It automatically scales it up for us. And the last one we have over here is when x is 7 and y is 9. So over here, we see that X is 7 and Y is 9 over here. So this one too is looking good. But almost all the time, when you do the matplotlib, you see something like this. This matplot.collections.whatever things you see over here. And you don't really want to see this. So what you can do is you can do plt.show. Now, when you do plt.show, it takes care of that, whatever thing you see over there. Okay, so this is just the basics, okay? Now, even with the line plots, okay, this is just plotting X. You can also plot Y and have multiple lines being plotted on a particular space. So let me do that one over. I can do plt.plot and I'll pass Y and then also I'll pass X and Y. So now when I do this, we have, let's see the values proper. So we have 147 for Y, sorry, for X. So 147. So this one will be this one, okay? 147. Let me see, 147. Okay. And then this one is Y is 1059. 1059. So I believe I have 10 over here. 5 will be somewhere over here, and then 9 will also be somewhere over here. Okay. Now let's look at how we can change the color, because maybe there's not the default blue is not what you want. So what I can do over here is I can do a comma, and then I can put this in a string. Now when I do R, there are different colors that we can use. Okay, when I do R is going to be red. So when I run this, you see that now the line changes from blue to red. I could have typed in red over here, but Matplotlib wants to even make it very easier for us. So I can do this. Now I can type in any other color. Okay, so I can type in brown, green, and stuff like that. But then once again, instead of typing green, I can do G, and it's going to give me the same thing. But then the interesting thing is when I do B can be black or blue, okay? So by default, it is going to be blue because the default color itself was blue. So blue is the default. But then if I want black and I don't want to type in the whole black, I can just do the key. And this is going to give me the black this way. Okay, so this one looks good. Now there are few things that I can do in here. Now let's say, yes, I'm doing a plot over here, but then I wanted the point to show. Okay, so the point, I can do 0 or O, not 0, but then O. When I do O, now I don't have the line, even though I'm doing a plotting, okay? I have the dots showing up over here. And then I can do a comma. And then I believe B, let's see if this one, no, I don't think there's no comma over here. So when I do OB, yes, I want the dots and I want it blue. So I have it over here. When I do OK, that means I want the dots and I want it black. And that's precisely what I have over here. Now, instead of dots, I could have done, let's say, 2 dashes over here. So this is going to be a line, but then a line, dash lines. So I have these dash lines over here. And now when I do, for instance, dash line and a 0, that means I want the point to show. And inside of it, I have my dash lines. And that's exactly what you see right there. So the point is a 0 and the dash lines are the dash lines we see over here. So now this becomes very handy when you have a lot of lines that you want to be very specific, show the distinction between this line and that line. So for instance, one line can be a dot and the other line can be whatever. So now let's do this. So I can do plt dot another plot. Same on that particular graph, and then I'll do Y. And let's say this time around, I'll do, let's say, I'll do a normal line, but then I want it red. So now when I run this, you see that on the same plot, clearly this one is showing me that, okay, this is a red line. So this one is, for instance, maybe some value I have no idea of, okay? But then the key things are showing up over here because we have 10, 5, and 9. We have 10. This is the point over here. Then we have 5 over here, and then we have 9 over here. I can be more specific and let's say it's a star over here, or maybe another 0. So another 0 is also going to put the dot at the point. So when I do this, that's what we have over here with the red. But then if I want the line, maybe I can do, if I do one dash, it's just going to be without one line. Okay? But a double dash is going to be the dotted lines as we have over here. So this one makes it even more clearer in terms of what you want to visualize. Yes, want to have 2 lines on the same plot. Maybe you want to compare something that I have no idea of. But then later on, when we build our models, we are also going to compare, for instance, maybe accuracy versus the logs and other things, and we can plot everything on the same graph. Now, let me quickly touch on some other key things. So now that we have these plots, let's see the other things, because normally whenever we have plots, we have, let's say, some labels, okay, for the x-axis and also for the y-axis. So in order to get that, I can do plt dot x label this way, and then I pass in whatever thing I want to have on that x label. So let's say this is, let's say, data sets, okay. So now when I run this, you see that I have data set showing up over here. Now, clearly, if I want something for the y side, based on what we have so far, I can do plt.y. Copy this, Control V, and then plt.y label. And then I'll pass in, let's say, something like values. So now I have my y label showing up over here, and I have my x label showing up over here. Now, what about a title? Okay, if I want a title, that one too is very simple, plt.title. Then I pass in whatever title I want. So I can say lots of data sets. So when I do this, I get plots of data sets, I get my y label, and I get my, how do you call it, my x label showing up over here. Now, as we move along, we are going to see that we can do a number of things over here. So for instance, maybe the font size is not okay for us. Okay, they look very small, we want them big. So I can come inside of whatever thing I'm plotting as my x label, and let's say I'll specify a font size attribute over here. And this is going to be in pixels. So let's say I put in 20 over here. So now when I run this, clearly you can see that this is now a little bit bigger than what we have over here. Okay, then maybe my title size too is looking too small. So I'll do a font size this way. And this one is 20. Okay, so this one is looking much better. Let me do a plt show to get rid of this text as well. So plt show. So this is not a lot, but then you clearly see that, like I did indicate, the things we know. Okay, we know that there's an x axis, there's a y axis, and whatever thing you want as a label, there's a title, you have a font size, stuff like that. We can also specify, for instance, some, what I'll say, padding. Okay, those of you who have done a little bit of web development and some UI design and stuff like that, we have something we call margins and paddings. Okay, so for instance, you see the distance between my plot of data sets, okay, this title, and then the actual thing, like, it's too close. Maybe I want it a little bit wide. Okay, so I can give some padding. Okay, so over here I can also specify something we call label pad, and over here too, let's say I do a 20 over here. So I just want some space in here. So now when I do this, I have an error showing up over here. But then these errors, later on, you are going to see that. Okay, so these errors, later on, you are going to see that they are going to be very helpful. Okay, and I'm going to show you a typical example where we can intentionally put out an error to help or guide us get a correct thing. Okay, this example is not going to be helpful, but then the other ones are going to be. So I think the label pad is not helping us. It says, set title, and then you can get, okay. We need to set the title first. But then we can have the the pad. Okay, so now let me try pad and see. Okay, so I think pad is a new thing. So once again, I'm going to show you something. So when you move along with these libraries, they get updated all the time. And as they go on, some of the functions and methods over there, and even the way things are, they get deprecated. Okay, we are going to see an example very soon. I think that they tend to take away certain things and introduce things. Some time ago, it was label pad, now it is just pad. So now clearly you can see that the distance between what we have over here has now increased. Let me make it very obvious by doing a 50 over here so that I'm very tell you that there's that gap. But maybe you don't want it 50, maybe a 15 will do. So this one looks good. And then let's also, this one, I think the font size, maybe 10 will do. 10 is too small. 14. Okay. And over here, so I can apply same font size on this. So our plot is looking much better. Okay. Now I'm going to run you through the very basic things. So let's say after plotting this, I want to now save it. Okay, I want to have it saved and work on it. Maybe put it in a report or something. So in order to save this, I can also do plt dot save fig. Okay, save fig this way. And now I pass in the name of whatever or how I want to save it. So I want to call this, let's say, data sets underscore plot.png. So this PNG is the file format I want to save it. So now when I run this, everything looks good. Now, if I go back into my folder, I'm going to see it's over here. So data sets underscore PLT. And if I open it up, that's precisely what I have over here. And these ones, the images are very sharp. Okay, so when you zoom, you get things looking very nice. And with what I was trying to show, let's say if you have a report and you have to put in some plotting and stuff like that, you can just come in here, copy your image. Let me just copy this. Control C, bring it here. And then, I mean, your image is looking very sharp, even if, I mean, when you squeeze it up, I mean, it's still looking good over here. So everything looks good for your plots, and you can do some other things. Now let's make even this even better, okay? In that, the big question is when you are trying to visualize data, you need to be very pragmatic in your approach, okay? And being pragmatic, it's okay. These lines probably mean something, okay? You are not communicating it here yet. So we can put in a legend to tell anybody reading or visual, I mean, looking at this data, know that, okay, maybe this red line is representing temperature and this one is representing humidity. So clearly the person upon seeing that, okay, red line is temperature, that means the temperature was up, it dropped in the but then humidity was just going up in that forward direction. So that one will add more sense to whatever thing that you are trying to communicate. So we can put in a legend over here. And look at this. So you see that it is on this X label. Okay. On this, no, not on this X label, but then on this plot, okay. I can pass in a legend on this because this is where I have my whatever. So I can do legend over here and I can specify a name. So let's say I call this one is the so this one is humidity. So I have humidity over here. So now when I run this, oh, let's see. Okay, unexpected keyword legend. Okay, no problem. Let's do it this way. Okay, so let me come back here and let's do plt dot legend and let's pass humidity. Okay, so when I just do plt.legend, I mean, everything is showing up as, I mean, this legend over here, okay? But then it's not exactly what you want. You want to specify the, for instance, the red for this particular one, and the yellow for one particular one. So let me call this, let's say, legend 1 is equal to this. And then legend 2 is going to be equal to temperature. So let me just do Control-C, Control-V, and let me call this 10. Okay, so legend 1 is equal to this. Now clearly, okay, so I have the blue one showing up as temperature, and then, I mean, it's basically almost the same thing, but then no problem. But I mean, you get the point. We can make this a little bit better in terms of how it looks. So let me try and put legend 1 on this and see if this one is going to work. Okay, so now let's look at the attributes that we have over here. We can pass in these ones. I think I'm missing out something over here. I'll find out and get back to this. But then we get that now we have a legend on it. Okay. Now with a legend, we can be more specific on actually where we want to put this legend. Okay, so let me just get rid of this one. We can be more specific on where we want to put. Yes, Philemon.
I realize that if you put the inside the plt.legend, you put the legend inside as a list, it's arranged it.
Okay. Yeah. That's good. So you put it inside as a list. Good. So let's have humidity over here, temperature. Yeah, that's good. All right, good. So now the legend is showing up on this plot. Okay. Now, what we can also do is sometimes the position of the legend may not be as great as we want. Okay. So maybe I think it would be better we put it maybe at the bottom here. So what we can do is we can pass in a location. So I can do log is equal to, and this is where it gets interesting because over here, let's say I put in center. I run this and now it is at the center. Okay. Now this is even worse than where it was. So now I can specify, let's say, a top right. When I do a top right this way, now tells me that there's a problem. I think I had the spelling of, okay, no problem. But then this is actually going to help us get some few things because like I said, some of these errors actually guide us. So you can see that it says there's a value error. It says top right is not a value for the location. The supported are, so this one is even giving you help on what to do. So I think instead of saying top right, I can say upper right. I think that's the right one, upper right. So upper right is over here, upper left is over here. So like I said, these errors, whenever you see them, don't get scared. Just come down here, read the value error. Sometimes they get some guidance on what to do. So instead of the top right, I can now do the upper right. So now upper right is looking good. That's where it was. So now I can do lower right so that it puts it at the lower. So I think this one is perfect in terms of whatever thing you want to combine. So anybody who sees this knows that, okay, for the blue line, it is dealing with humidity and it is always going up. But then in the case of the red line, it was temperature and it can come down and go up. This is even more better in terms of data visualization. So this is just the basics, okay? Now let's quickly move on to instances where we can, this one was, okay, this one was the scatter plot, okay? So with the scatter plot, we can do, for instance, the title and other things, okay? Now let's deal with our very own data set that we very much. So let's data set is equal to pd.read_CSV. I have this pandas data, I mean the iris data set over here. So I want to import it in. Let's go back to the iris data set and do some investigation. So I run this, and then we've seen this over and over again. This is the original one, okay? There are no now values and stuff like that. So when I do dataset.info, we don't have any problem. Everything is filled up. Okay, we are good to go. So what I want to do is, okay, so the last time we spoke about the how do you call it, the correlation and other things, okay? And today I want us to have some kind of a plot of the correlation and how things will look like if we are actually to do this properly. And we're also going to use the seaborn. So what I'm going to do is, first of all, you need to have that correlation. So let's say correlation data is going to be equal to our data sets. I think I need to drop something over here, but then let's see our data set.co. I think I need to drop the species over here because these ones are not numeric values. Okay, I think the last time we were dealing with this, we saw this. So let me call this data is going to be equal to data set.drop. And what do I want to drop? I want to drop species. So because the correlation is always going to be between how do you call it, numeric values. Okay. I need to specify columns over here. So columns is equal to this. Okay, so now the data is looking good without the species. And I think the IDs are just some numbers that are increasing. Okay, they are not adding any value to our data set. So I can drop that one as well. And I believe I can put this inside of a list this way. So this one is ID. Okay. So now I have the species and IDs. So now I can get a correlation. So I'm going to say before underscore data equal to the data that we have now. I call it this way. So now let's do a preview of the correlation data. So this is the actual data that we want. We want to get a point out of this, visualize it in order for somebody to quickly look at it and make sense out of it. Because now if I look at it as it stands, I have to look at 0 point something and stuff like that. So over here I can do SNS, which we have already imported as if there's a heat map one over here, which is very interesting. So I can do SNS.heatmap, and I can pass in this correlation data, which is originally this data frame as we have over here. So now when I pass this one here, we get an interesting plot. Okay. Now, for now, it may not make sense, but then let me try and explain something. So then you see that we have the various labels as shown over here. So the sepal length, sepal width, and all those things, just as we have over here. Okay. And these values have been taken and we have a plot of it. So it is just comparing both. But then we may also want to, for instance, maybe get these actual values. So these actual values are going to be annotations within the plots. Okay, so we can pass in annots and I'll say true. So now we get these values showing up over here. Now this one becomes very obvious. Anybody seeing this will know that, okay, anything, for instance, that is a little bit dark, okay, it is within this region, like a 0.4 to the 0.2 region. I mean the negative, okay. So anything, this one is very dark. So okay, these ones are the least. So clearly I can see that in terms of correlation, for instance, if you have to compare sepal width and then the petal width CM, the correlation is negative over here, okay, in that as petal width increases, this one decreases, okay, and we can actually take a critical look. Okay, so petal width, which one was that? Petal width CM and sepal width CM. So let's look at this. Petal width CM and sepal width CM. So these two. Okay. And we are saying that there's a negative correlation. So this one was increasing and this one was down. Now, clearly you see that this one, decreased, for instance, from 3.5 to 3.2, and this one was also kind of playing along. And then it decreased further over here, but it decreased to 3.1, and now we are seeing an increase over here, 1.5. I mean, if you have to compare the first one over here, 3.5, decreasing to 1.5. But then this one has moved from 1.4 and increasing. So there's that opposite direction, okay? And we can do the comparison with other ones. These are just some brief snapshots of it. And over here too, let's say we were at 2.5 and we kind of, let's say 3.0, the values are not in order, unless maybe we sort this one. So let me see in this original data set. So let me do data dots sort, and what do I want to sort by? I want to sort by, yes. Let me do a like over here. Data frame. Okay, sort values, sorry. So sort values. I think this one is items or something. Item. Okay, just this way. So we've sorted the values based on the sepal length CM. And what were we comparing? We're comparing sepal length CM and the petal width CM. So sepal length CM and the petal width. Okay, it was these two. Sepal, okay. So this one and this one, okay. And we are seeing that there's a negative correlation with it. So when this one is increasing, this one is decreasing. Okay, so now that we have these sorted out, let me just do let me just do dot head and passing 20 over here. So the first 20 rows. Okay, so we are comparing sepal with the CM and the petal with the CM. So this one and this one. And we are seeing that there's a negative correlation, okay, of a 0.36. And what that means is, okay, if this one increase, this one should decrease, and if this one decrease, this one should increase. That kind of correlation, because it is in the negative direction. So over here, let's see. Now, if it is it, I think the sorting, let's do the sorting by this one. So let's accuracy for us to see. Okay, good. Now, we had an instance where it was a 2.0, it moved to a 2.2. Okay, so these ones were also moving as well, because these two are the ones we are comparing. Now, it went to a 2.3, then all of a sudden, you see that there was a drop over here. This one dropped to a 0.3. So this one increased, this one decreased. So it was in that negative direction. And you see that this is very sharp in terms of the increase. Then it went to another 2.3. There was an increase over here. Then it went to a 2.3, still at 2.3. And this one was decreasing. There was a sharp decrease over here. Then went up, it is decreasing. It is almost, I mean, moving in the opposite direction, okay? Because even when it increases, it decreases again. So clearly we see that this one, it's increased, then it decreased, then it increased, then it decreased. So definitely there's no, I mean, that's, I mean, an instance where you can say it increases and it increases all the time. A lot of the time it decreases, and we can see that over here as well. Over here it increases, it decreases, it further decreases over here. So there's like 2 depreciation counts over here, but then this one was being maintained at a 2.5 all around. So clearly we can explain that, okay, this one is a negative. In the case where, for instance, this one was a positive correlation, okay? So what it means is, okay, if petal length increases, sepal length will also increase along the line. Okay, So a 0.87. So now let's sort by petal length, cm. So let me just come and do petal length cm, Control C over here. So we are comparing petal length cm with the sepal length. So this is the petal length cm and the sepal length. So these two. And we are saying that if this one increases, most of the time this one will also increase. So let's say we're at a 1.0. Okay, there was a drop over here, but then this could be the few outliers. Then we came to a 1.2. There was an increase over here. We're still maintained at 1.2. There was no significant increase, but then we came to a 1.3 and there was an increase over here. 1.3, there was a drop. 1.3, there was even a further drop. 1.3, we kept having some drops over here. And then 1.4, this one increased and this one also increased. Okay, it didn't increase. And then this one stayed at where it was. This one was, it increased. This one comparably, it's increased. And we can go in and in to see the correlation between those two values over there. But then there's just one way of handling things. Now, this one looks good. So, yeah. Now, we can change the colors as we have over here. So this one is going to be color one. So I can use it. And for instance, if I do red over here, then I want everything in some kind of a red color. Okay, so now I have this red over here. I can do purple. So when I do purple, okay, once again, this one is telling me that there's nothing like purple, but then if I come to the bottom over here, okay, this one doesn't give me those options. But then let's say this one, okay. Okay, so now let's do green and see. So I'll do greens. Foster, yes, Johan is up.
Okay, sir, please, sometimes when you hit Shift tab inside the function, it should give you the details of the function. Inside the details, you might see the
Okay.
possible CMAP values.
Okay, all right. Thank you very much. So that's a pro tip. Okay, so now when we do greens, we get these greens over here. So it depends on really what you may want to do, okay, along the line. Now, there's also another attribute which we call the line width, okay. So the line width, now clearly you see that there are some lines over here, but I think by default it is set to 0. It is not obvious. We can put up a very good line width line width. And let me set this one to a 0.6. So now when I run this, now you can see that it is very clear, okay, the lines in between and stuff like that. Found with a 0.9. Then this one is even very clear. So it depends on what you want to do and how you want things to be. Okay, so that is just with the heat map. Now there's an interesting one over here that I want us to look at from the seaborn, okay, because the seaborn is very interesting. Now I want us to have the original data set, which is this data frame we have over here. So now let's quickly come down here and do this preview. So I have these data sets showing up over here. I have the original one with the IDs and also the species. Okay. Now we are going to do a pair plot. Okay, so I can do SNS.pair plot. And as the name suggests, this is going to do a plot of all the attributes, okay, or all the columns paired to each other. Okay, so if you have to count this, how many columns we have? We have 1, 2, 3, 4, 5, 6. So it will pick, for instance, ID and pair it with all these ones, pick sepal and pair it with all these ones, and it goes on and on and on. So we are going to have quite a huge plot. So if I want to do pair plot, what do I want to have as a data set? I want to have this data set, okay, this entire thing, do a pair plot of this. So now let me do plt.show just to get rid of any other thing that we have. And this one, like I said, you see, whenever it's running, it takes a while because if the data set is huge, it might take a little bit of time. But then here we get the plot and it is looking a little bit interesting. It is looking a little bit interesting, except that there are some ones that we don't need. For instance, the ID. The ID does not make too much sense to our data sets. So I can get rid of the ID, or at least for now, let's just move on. So now we have this, and for now, it is not conspicuous, whatever things we are dealing with, okay? But then we are plotting this, and these dots we see over here, these scatter plots, are basically the plots based on the species over here. So I can specify a hue, and this is rather going to show what I'll say, some distinction for me. Okay, so I'll say the hue should be species. So I'll run this once again, and the next plot that will come will be, I mean, better than what we saw previously. All right, good. So now this is a legend, it's automatically comes with. So it says that based on the species, okay, anything you see as is Iris setosa, anything you see as the orange is Iris versicolor, and anything you see as green is the Iris virginica. Now, like I said, these things that we are seeing over here in terms of the visualization is going to help us with identifying outliers and stuff like that. Okay, so clearly you can see that all the blues, okay, which is Iris setosa. Let's look at this particular one. Okay. All the blues, which is Iris setosa, are clustered along this line. Okay, so if I'm to draw, let's say some kind of a line over here, none of them is beyond up to a certain point. So imagine all of a sudden you see one blue showing up over here, or one blue in the middle of all these greens, then clearly chances are it is an outlier. So you can, I mean, zone in and see what particular data it is and why it is actually there. And we can see, but then this also helping us see some few things. But then let's look at what it actually means. So for instance, when we look at the petal width CM, and these are the specific values inside of the data set, and the sepal length CM, okay, so this is where it is plotting the petal width and the petal width CM and the sepal length. We see that, okay, with all the Iris, the blue ones are the Iris setosa, with all the Iris setosas, you can see that it is within a range of 4 point something, okay, or within a range of 4 in terms of the sepal length to a range of 6. So once again, like I said, if we're having like something over here, which is like 8 point something, based on the markings we see over here, then we have a sense of, no, this one will definitely be an outlier because all the other ones are tightly close to each other, okay? Then in terms of the petal width CM, you could see that, okay, it is all within a range of, look at the markings we have over here. This is a 0.0. We have a 0.5. So none of them, okay, is going beyond the 1. So if you also have something over here, something like 2 point something, then clearly we don't have, I mean, we can clearly, at least it gives us a red flag to further do an investigation and see how things go. But then there's one interesting one I have over here. For instance, with this one, okay, this one is the sepal length CM as against the sepal width CM. So it is sepal length versus sepal width. And you realize that the Iris versicolor and the Iris virginica, okay, the orange and the green ones, see, the orange and the green ones are very close to each other. In fact, some of them are very close. So clearly, when you see something like this and maybe you see another orange over here, it tells you that, okay, based on the inherent nature, a lot of the majority of them, they are like intertwined, okay? So for this reason, later on, in fact, we are going to build a model from this particular data set, okay? And we are going to see that when it comes to predictions, that has to do with Iris versicolor and Iris virginica. A lot of the time, if there's going to be any misclassification, it's going to be one of those ones because they are very close in terms of their features. This is the feature, this is the values we have in there. And clearly you can see that these ones are very close. And not just these ones, you can see that all the oranges and the greens, the Iris versicolor and the Iris virginica, they are very close, okay? So even with this one, you can see that they are very close. Even with this one, some of them are close. These ones, they are clearly very close. These ones, the Iris setosas are the ones that are a little bit wide apart if you are to look at it in that general holistic sense. Over here, you can see that Iris setosa and, versicolor and virginica are very close. Setosa is a little bit further away, and the other ones as well, okay? So you can spend time and actually have a deep dive into these plots as we see over here. Okay, so now let's move on to some other things that are mentioned. So let's look at which one. I think we can use this one as an example, or maybe. Okay, let's go back to something that we can use as a pie chart, because pie charts, we're only concerned about the data. Okay, so let's say we have something like countries, and this countries is going to be a list. So np.array, and let's have a list of countries. So let's say we have Ghana, and I'm looking at, let's say, countries by their population. Okay, so Ghana, Nigeria, and then our brothers, Togo. And then let's look at population. So this one too is np.array. And then the population of Ghana is about 30 million, Nigeria is about 50 million, and Togo, I'm not too sure, but let's say 5 million for Togo. So I'll run this, and this is looking good. So now I want to have a pie chart, okay? So I can do plt.pie. It's as simple as this. And what do I want to have a pie chart? I want to have a pie chart of the population, okay? So I can say plt.show. But before I show this, let me also give out some kind of a title. Over here, we don't have X label, Y label. I mean, a pie chart is just that thing, okay? So I can do plt.title, and I'm going to say plots of, let's say, population plots. So when I run this, we have this showing up over here. So it automatically picks up these colors for us. We see how this one is looking. Now, the issue is, okay, it looks good, but then, like we saw over here, where we had to add in a legend to actually make sense of, okay, this line represents this particular attribute or data in there, and this particular line means this. We can also do the same thing over here, okay? And over here, we can pass in a label attribute. So in here, I can say labels. I think it is labels. It's going to be this countries as we have over here. So I'll put this over here. And now when I run this, clearly you can see that we can see that Nigeria is showing up over here, Ghana is showing up over here, and then Togo is showing up over here. And this calculation has been done. Now, when it comes to, especially with the pie charts, I don't find it a little bit interesting when you are using Matplotlib, because this is almost what it gives, okay? You can do other things to show the shadow and other things, but those ones are not as interesting as you probably may have it in Excel or something. So that's just by way. But then some of these ones are really good because it gives you a general overview of your data set and how things or how your attributes are interrelated. Now let me finish off with one last one, and that has to do with the histogram plots, okay? And let me just have this, yeah, these two data sets. We can use this one to get into it. So I can do something like plt.histplots, okay? And then I want to pass in population over here. And this population, okay, I think I'm missing things up over here. So it says Matplotlib has no histplots. Okay. This one is SNS Seaborn, okay. Okay, so this is a distribution plots as we have it over here. And what we see over here is making things a little bit confusing for us, because we get to see something like 0 to whatever and whatever to whatever. Okay, it's not really looking good for us. So I can do a comma over here, and then I can now specify some what I'll say relevant attributes. Okay, so I can put in the countries over here. I think I need to specify let me see this. Okay, it takes only one, but two were given. Okay, so let me see. I think this one should be not too sure. Let's see. Okay, so this one is going to help us. So we can put in the height, the width, the bottom line, and okay, all right. Let's get one from what we know. So let's grab something from this IRIS data set. Okay, let's say from the sepal length CM and get a distribution plot out of this. So let's say I can do SNS dot hist plots, and then I think the original data set as I have it over here is data set. Okay, but I want to grab this from data set, so I can do data sets over here and then slice it up. This actually whatever thing I want. All right, and this is what I get. Okay, now this is also helping us see something interesting over here. In that, you know, the bell curve. Okay, if we have something that is in that bell shaped, and when I say bell shaped, okay, so for the normal distribution that we have, let me see if this one will make sense. Okay, so for every normal distribution, and when we say no, I mean there are lots of distributions. So the Poisson, the Bernoulli, and all this, probability and those things. Okay, those of you in final year definitely will do it. So for a data set to be considered normally distributed, which means there are no outliers. That's the whole point. Okay? Or they are not, they are closely to each other. Okay, we have to have a central point, and that central point is going to be the mean. Okay, and now the standard deviation is going to be how wide you are away from the center. So for instance, let's say a typical level 100 class, okay, at the University of Ghana will have the average, which is a mean age, to be about let's say 19. Okay, chances are there are people in that class who will be 17 years. Now, when you look at the standard deviation, the difference between them, which is 19 and the age 17, is just 2 points. Is that okay? And chances are there are people who are 18. The difference is just 1. And there are people who are probably 20, 21. The difference is just 1 and 2. So let's say if this was 19 years, okay, and somebody is, let's say 18, then that person is within this region, okay? So maybe about 20 people who are 18. But then if you have somebody who is like, let's say 12 years, which is possible, you can have somebody who is in level 100 12 years, then that person will be further away from the mean. Remember, the mean is 19, somebody is 12 years. That means the person is like 7 years away from the mean. So that person becomes an outlier. That person will be somewhere here, okay? Getting, I mean, very, very, very far. And then if you have somebody who is, let's say, 30 years or 45 years, then that person will also be further away from the mean. So if you are to draw that plot, you see that that particular data point will be a lot of, I mean, miles away. So having said that, you see that, okay, this one is fairly distributed, okay? But then in order to have a sense of, I think this one is over here. So KDE, let me say true, good. So now this line, okay, is almost like the curve that we see over here. We can clearly see that, okay, this one, it is fairly distributed, but then it is a little bit skewed in a sense that it is not as perfect as we see it over here. There's like a perfect distribution. There are no strange outliers, okay? And this one is, we'll take it like that in terms of how it looks, okay? If, for instance, maybe you did some experiment and you had your distribution this way, it can be accepted depending on whatever thing you are working with. Now let's see for the other ones. So I'll do a control C. This one was just for the sepal length. Okay, let's do sepal width. So I'm changing this to sepal width this way. And now this one is even more distributed because you see that the curve is showing up clearly over here. So this one, you can see that the mean, okay, the middle point was a 3.0 in terms of the sepal. And now this one is showing us the count. The number of times you have things around 3.0 was about almost, if I'm not mistaken, above 35. Okay, to be correct, above 35. And we can count the number of times, for instance, things were below, we can count these plots and see that, okay, it was around, let's say, so this one is about 25, okay. This one is about 15. This one is about, let's say 12. This one is about 7 or 8. And this one is about 4 or 3. So we add these things up together. And we can also add this one. You can compare that, okay, below the mean and above the mean, there's some kind of fairness in there. All right. If you have something like, let's say, something which is strangely of an outlier, you can see that that one will show up with another plot over there. You can clearly see that there's an outlier over there. Let's do for the other part as well. So we have, let's do petal. So petal length cm. And for petal length cm, you can see that clearly this one, we have ones that we can consider outliers. Okay. It depends on whatever thing we are working with, but clearly you can see that the mean is around this point, okay, maybe a 4.5-ish thereabouts, or maybe a 5. And then we have a lot of them that is drifting away. A lot of them are showing up as 1, okay, and over here. So in this particular instance, if you are to look at it from an optimization point of view, where I don't know, maybe level 400, you did a little bit of that, where you looked at the global minima and local minima and all those things. You see that over here, we are getting 2 points of optimizations, okay? And these ones are really going to impact your work if this was like a very critical data set you were working with and you saw some of these things, then you need to find ways of correcting it. All right, let's look at the final one, which had to do with the petal length cm. No, that one is going to be the petal width. So let's do petal width cm. So I'll run this, and this one too is looking like this. But then this one also communicates something. So you realize that, okay, with the petal widths, they seem to be in this direction. Okay, because this one was petal width length cm, and this one was petal width. So anything that has to do with petal was a little bit skewed, and anything that had to do with the sepal was, I mean, upright in this sense, in terms of its distribution. So we have a sense of how our data set actually looks like. And this can come in very handy. If, for instance, you have about 1 million samples of data, you cannot look through each and every one to know that, okay, this one is an outlier and stuff like that. You can actually use these plots to quickly identify, at least you have a bird eye view of how things behave, and then you can correct things if they need to be corrected. Now, finally, I think, yes, and let me also point out this one, because this one too is very interesting. I just found out when I was doing a little bit of research this one. So this IRIS data set, you see that we can download the original CSV file from the, how do you call it? The UCI machine learning data set repository. We can also download it from Kaggle. We saw instances where we can also get it from, for instance, how do you call it? Scikit-learn, okay? Now, it turns out that even in Seaborn, you can have these data sets and also view them. So now, if I'm to say, let's say data, let me call this new data. So new data is going to be equal to sns.data, data set, sns dot, I think this one is load data. Yes, this one is load underscore data. Now I pass in IRIS over here. This one is going to load the IRIS data set. So now when I do a preview of this, I get this IRIS data set in its like data frame format. Okay. So over here, you can see that we have the sepal length. And I think here, the original one, okay, the one I just imported over here, this one, which is the CSV file, you can see that the names, no, please pay attention. It is sepal length this way and species this way, okay? So this one was like some camel case notation as we have over here. But then these ones have converted everything into separ underscore length, petal underscore length, and all those things as we see. But then it's the same data set, and we can do the same things with it over there. So we don't necessarily have to download it. But then these are like data sets everybody uses for some preliminary machine learning model development and also data visualization. So you can get these data sets. I mean, the ones that we spoke about almost everywhere. All right, so I think our time is up. I'd wanted to quickly start with, let me see. I think we've covered most of the things we need to cover over here. So for instance, the exploratory data analysis process, you see how you can explore our data using the pandas data framework, work out some visualization. The data generation we've seen alongside the preparation, finding classic balance. This one is going to be, at least we've seen that for some data sets, there could be some class imbalance. Okay, just by even visualizing it.
Hello.
Yes.
Yeah,
We've
Ken,
also
I'm
seen-
listening to you.
All right. We've also seen instances where we can visualize our data. Now, with the feature importance and relevance plots, we are going to look at it when we start, for instance, with the, I believe the decision tree is going to help us do that. And also we've seen a code. Now, with our next, we are going to look at the feature engineering, the model training, which we are actually going to build a model, and then the performance accuracy, because we need to build a model before we can actually check it for the performance and other things. And later on, all these things are just going to fall in line based on what we are going to implement. All right, so I think I'm done for now. Please, any questions?
Hello, sir, please, can you hear me?
Yes, please, I can hear you.
Okay, so the last part of the coding, the part that you use the load underscore data set.
Yeah.
Yes, this part. I tried doing the same thing, but it's telling me that Iris is not one of the example data sets. Why it?
Okay, so it is possible, and that's why I said some of the libraries get updated all the time. So a lot of the time, some of the things that are possible now may be a little bit different in some years to come. Okay, so let me show you a typical example. I think this one is it is in SNS dot. Let me do this one. This plots. I just want to show you. Let me just grab this. Okay, new data. Okay, somebody says check the capitalization to maybe is the problem. Okay, so I think the iris should be small letters as we have them over here. But then let me show you what I wanted to point out with the thing that I was speaking about. So this one is showing this plot. Okay, so let me do PLT because there is another one that's I've used for sure, and I had issues later on because it was telling me it would be different. Okay, let me see. Yeah. Okay. Okay, so let me see. This one was using the bar. No. Let me check for other examples. Okay, so this one is the Matplotlib official website, and when you use something that is soon to be deprecated and taken out of the system, that going to components of some versions of the library are going to go off soon. And if I wish I could remember that one. It was one of the plots that's okay, so let me see. What's plots? Is it histogram? Okay, I think dots hist very good. Oh, no, these ones are not what I want. Is it the histogram? So let's see this one and see. Oh, I just wanted to show that because don't worry, I'll find it, and maybe the next time we meet on Tuesday, I'll show you that, because that one will give you that warning. Okay? And I think that's what Philemon, when he was doing the presentation, wanted to avoid, because some of those warnings are not yeah, like for instance, this one, okay. So it's given as a user warning that the figure layout may change to tight. So talking about the size of the figure, let me just quickly, because this one too can come in very handy. Some of the things that you mean. So let's say we have this, let's have a plot. So X is going to be equal to np.array, and let's say 1, 2, 3. And let me just do this one just for the next 2 minutes. And let's say y is equal to this 2040, whatever. So I just want to have, let's say, a plot. Okay, so plt.plot, and then I'll pass in x and y. So this is what I get for the plot, okay, based on the x and y values that I have. Let me just make things a little bit look cool. Okay, so there's a plot. Now let's assume I want this to be much bigger in terms of the shape, or to be much smaller. Okay. All that I need to do is I can do plt.figure, and then I specify a fixed size over here. And this fixed size is going to be in terms of the length and width of the pixel. So let's say if I do a 4:9, you can see that it is not too obvious over here, but then let's do something like a 10:20. This one too is not too obvious, but then for some of the plots that we'll be dealing with, we would need to specify, for instance, a very good figure size, okay, in terms of how we want it to be, in terms of it's how large or how small. Okay, and some of these things are going to come in with this. So it says the figure size is 100 by 200 with axis 0. Okay, so let me see. It's not even helping us. Okay, so we can look at this, but then this is just to show you how we can change the figure size. If it is too small, we can make it big. If it's too big, we can make it small. And see how we go from there. Okay, so I think we are good. I think the next time we meet, there are some few things that we need to go through. For instance, just to do a refresher of the entire machine learning thing. Now it's almost as if we've done a lot of data pre-processing and stuff like that. And yes, these ones are very important. They are what I refer to as the peripherals. Once you have a very good data set and everything looks clean, the algorithms are already there. We just put them inside and figure out things as we go along. So the next presentation, we are going to go through some few things I have over here, and then you understand some of the basic concepts that will tie into some of the things that we are learning now, and everything. Okay, thank you very much. And if there are no questions, I think we can close for today. Please, are there any questions? All right, sir, Dr. Mills.
Yeah, okay, I'm on the line. Okay. So what I was thinking of is now the data preparation, if we have done enough of that, probably it's left with the feature selection and then the feature importance and the class balancing problems. Yes, if I also want us to start with the machine learning model development as quickly as possible.
Yeah, sure.
So is it possible that we can start the development to,
next
Tuesday?
Week. Yes, sir, sure.
So that we find out a place where we can slot in the feature importance, those sort of things. They are very important in the machine learning model. Yes. We know in the previous 3 years that we have done, we didn't consider that as a key thing, what we call the class balance, about the feature importance. But in recent development, papers that are published, people are focusing a bit more on the importance of the features. That is why this year we have introduced that into it. Okay.
Yes, sir.
So let's see if we can make time to slot that one in, maybe like 30 minutes or so, and the feature engineering. Then we go straight into the machine learning model development.
Okay, sir.
Okay. So, team, members, are there any issues that we need to take note of? If not, then I guess going back again to the data that you have generated, let me just, okay, instead of saying generated, we can work on that, the generated data, or we can visit the Kaggle or the UCI or the MIT data set, public data set, and then see if we can extract, we can get data for our respective departments. Or when you go to Kaggle, you see that there are a lot of projects that are data source that are there. And we can pick any data source that is of interest to us. What I wouldn't want us to do is that we shouldn't take images, because when we come to the convolutional neural network, that's when we'll be dealing with the images. So you can take any data that is available, labeled data. Data should be labeled data so that you can play your hands on with what we have done so far. So that, because next week we are going to start with the machine learning model development. Okay. All right. So we wish ourselves a good weekend. Okay. And we meet next week, God willing, next week.
All right. Thank you, sir.
Okay. Bye to everyone.